Hello, and welcome back to part 4 of the 6-part series looking at the feasibility of rainwater harvesting in arid environments. In this video, we'll be looking at the area that can be cultivated solely using the harvested rainwater we determined in video 2, as well as the net irrigation we simulated in the aquacrop model in video 3. Here is the outline of the videos. As mentioned, the rainwater harvesting equation gave us the volume of rainwater that can be harvested during a normal, dry, or wet precipitation year. In part 3, the aquacrop model simulated the net irrigation as well as the dry yield of maize or corn. Part 4, we'll be looking at the area that can be cultivated using that information that we determined in part 2 and in part 3. And then in part 5 and 6, we'll be going through the cost and maintenance needed to implement a rainwater harvesting system and a run-through example based out of northwestern Arizona on the Wallapai Reservation. So for the area that can be cultivated solely using the harvested rainwater for corn, the net irrigation was simulated from the aquacrop model, and the net irrigation is just going to tell us, again, how much water is needed for the crop to grow healthy and be harvested at the end of the growing season. And for this simulation, it determined that 1.06 feet or 322 millimeters of water is needed to sustain a healthy crop. We also need the rainfall depth, which was determined or calculated in video 2 using information from the Prism Climate Group website for Peach Springs, Arizona. And this is just a sum of precipitation averages for a normal year during the growing season from April to September, which was 0.379 feet. And that's just the average rainfall that is falling during April to September for a normal year. And with that information, we were able to determine the volume of rainwater that can be harvested, which we calculated to be 783 cubic feet or 5,857 gallons. And here is the rainwater harvesting equation. Just to reiterate, the rainfall depth is just the rainfall for that time period multiplied by the area of the catchment, in this case the roof, multiplied by the runoff coefficient, which is determined by the material of the catchment. In our case would be galvanized metal. So in order to determine the area that can be cultivated for corn, we are going to divide the rainwater that was harvested by the net irrigation, meaning that the irrigation is going to be supplied by the harvested rainwater. Because of this, we get an area that can be cultivated for corn, which is 741 square feet. So this is just for the normal precipitation year. So how much would we get if we had a dry year? So during a dry precipitation year, we should expect less rainfall and probably warmer temperatures, which would, of course, simulate a higher net irrigation, meaning that more water is required by the crops to stay healthy. And aquacrop simulated that to be 1.1 feet or 337 millimeters. The rainfall depth was determined to be 0.256 feet, which makes sense since we do expect less rain during a dry precipitation year. And the volume of the rainwater that can be harvested was 529 cubic feet or 3,957 gallons, which checks out. It's less than a normal precipitation year. So we should expect that the area that can be cultivated for corn to be less than the normal precipitation year, which indeed is at 479 square feet. So for the wet year, we should expect less of a net irrigation to sustain a healthy crop, which in this case, our crop simulated it to be 1.04 feet or 316 millimeters. The rainfall depth was a total for April through September at 0.373 feet. The volume of the harvested rainwater was calculated to be 769 cubic feet or 5,752 gallons. The area that can be cultivated for corn during a wet precipitation year was calculated to be 742 square feet. And this checks out since it is greater than both the dry precipitation year and slightly higher than the normal precipitation year. And there's some interesting things that I discovered, which I will be talking about in video 6. So now that we determined what the area that can be cultivated is, we also would like to know how much that area is going to yield for the crop to be harvested. So the dry yield of corn is simulated in aquacrop model as a ton over hectare. And the reason for this is that the aquacrop model tends to do a lot of their calculations in the metric system. But if you want to convert the units from metric to English, we will have to convert the pounds over square feet. This will then give us the actual yield when we multiply by the area that can be cultivated solely using the harvested rainwater. So here's an example. So if the model simulated that I can harvest 14.2 tons of corn during the growing season, when you multiply that and convert that, we would end up with the area that can be cultivated for a normal precipitation year of 741 square feet. By doing the unit conversion and multiplying it by the cultivable area, we get a harvested dry yield of 196 pounds of maize. So again, this is only for a normal year. So what about a dry and wet year? So for a dry year, we should expect less at 126 pounds of maize or corn. And then for a wet year, we actually get about the same as a normal year. And that's what I mentioned about some interesting things that I saw with the data, which I will be discussing in our run-through example in video 6. So that was a quick video on how to determine the area that can be cultivated, as well as the yield of the crop in pounds. In the next video, we'll be looking at the cost of maintenance, and then we will be doing a run-through example that kind of encompasses all the various parts of this video series into one, hopefully not that long video. If you have any questions about the project, please feel free to contact me at Brianda Hernandez at outlook.com and Dr. Maureen McCarthy and or Dr. Alex Lutz at their respective emails. Thank you.